Hello viewers, in today's class we are going to solve some important problems on maxima and minima. So here the first problem is, at what points the slope of the curve y is equal to minus x cube plus 3x square plus 9x minus 27 is maximum, right? And also find the maximum slope. Now this is a problem from maxima and minima, and the equation of the curve is given to us, and we have to find the points at which the slope of the curve is maximum, right? Now we know that the slope of a curve is defined as the derivative of y with respect to x. So suppose this is the curve, and this is the tangent at the point say P. Then the slope of this tangent, right? The slope of this tangent at some point x comma y is given by dy over dx. Now let us denote the slope by the letter m. So m is dy over dx, and the derivative of this function is minus 3x square. The derivative of x cube is 3x square plus this is 6x, and this is plus 9, right? And the derivative of minus 27 is 0. Now see, here we have to maximize the slope, right? The slope. So m is a function of x, and it is minus 3x square plus 6x plus 9, right? Now this is the function which gives us the slope of the tangent to the curve at any point P x comma y. Now we have to maximize the slope, because we want to find the points at which the slope of the curve is maximum, right? So let us now differentiate m with respect to x. So this is dm over dx is equal to minus 6x plus 6, right? Okay. Now the derivative of m with respect to x is minus 6 plus 6, and for m to be maximum, right? For m to be maximum, dm over dx should be equal to 0, right? Because for the stationary points, the derivative should be equal to 0. So we have minus 6x plus 6 equal to 0, and if we solve it, then we get minus 6 equal to minus 6, and x is equal to 1. So the stationary point, this is the stationary point. So x is equal to 1 is the stationary point, and let us now differentiate equation 1. So what we'll get? We'll get d2m over dx2 is equal to minus 6, because the derivative of x is 1 and the derivative of 6 is 0. So we have minus 6, and we see that if we substitute x equal to 1 in the second derivative, then the value of d2m over dx2 at x is equal to 1 is minus 6, which is less than 0, right? Now by the second derivative test, we conclude that x is equal to 1 is a point of maxima. This is a point of maxima, and the maximum value of the slope can be obtained by substituting x equal to 1 in equation say A, right? So the maximum value of m is equal to minus 3 times 1 square plus 6 times 1 plus 9. So this is minus 3 plus 6 plus 9, and it is 12, right? So therefore the maximum value of the slope is given by m is equal to 12, and we have to find the point at which this maximum value of the slope occurs. So we have x is equal to 1, and y can be obtained by substituting x equal to 1 in the equation of the curve, and this is minus 1 cube plus 3 times 1 square plus 9 times 1 minus 27, right? And if we simplify it, we'll get minus 1 plus 3 plus 9 minus 27, and if we solve it, we'll get minus 16, right? So therefore the required point is 1 comma minus 16, and at this point the value of the slope of the tangent to this curve is maximum, and the maximum value of the slope is equal to 12. Now let us take this problem. It is given that at x equal to 1, the function, this is given by x raised to 4 minus 62x square plus ax plus 9 attains its maximum value on the interval which is given as 0 to 2. Then we have to find the value of a, right? So here at x equal to 1, this function attains its maximum value, right, in the interval 0 comma 2, and we have to find the unknown value which is a. So we have to find the value of a. So what we will do, we'll differentiate this function, and the derivative is given by f prime of x is 4x cube minus 124x plus a, right? The derivative of x is 1, and the derivative of 9 is 0, and the derivative of x square is 2x, and the derivative of x raised to 4 is 4x cube, right? Now it is given that this function f of x has a maximum value, right? It has maximum value at x equal to 1, right? So what will happen? So here f prime of 1 must be equal to 0, because if a function attains its maximum value or minimum value at some point, then we can obtain the derivative equal to 0 at that point, right? Because the given point is a turning point, and the derivative is 0 at that point because the tangent is parallel to x-axis, right? So f prime of 1 is equal to 0. So here we'll substitute x equal to 1. So we have 4 times 1 cube minus 124 times 1 plus a is equal to 0. So this is 4 minus 124 plus a is equal to 0. So this is minus 120 plus a equal to 0. So a is equal to 120. So therefore the value of a is 120 when this function attains its maximum value at x equal to 1. Now let us take this problem. Here we have to prove that the function f of x, that is sine x plus root 3 times cosine x, has the maximum value at x equal to pi by 6. So this is the function. Now let us differentiate it. So f prime of x is equal to the derivative of sine x is cos x, and the derivative of cos x is minus sine x. So we have minus root 3 sine x, right? Let us call this equation as equation number 1. Now for maximum or minimum, the derivative should be equal to 0, or in other words we can say that for stationary points f prime of x is equal to 0, or dy over dx should be equal to 0, right? Okay, so now this expression cos x minus root 3 sin x is equal to 0. So we have cos x equal to root 3 sin x, and now this becomes cot x is equal to root 3, or tan x is equal to 1 over root 3, right? Now we have to solve this equation, that is tan x is equal to 1 over root 3, and from here we see that the value of x can be written as pi by 6, and the other values are 7 pi by 6 and so on, right? So here the value of x is obtained as pi by 6, and now let us differentiate equation number 1 in order to get the second derivative. So f double prime of x is equal to the derivative of cos x is minus sin x, and the derivative of sin x is cos x. So we have minus root 3 cos x. Now this second derivative, which is d2y over dx2, can also be written as minus sin x plus root 3 cos x, right? Now if we substitute the value of x equal to pi by 6 here, then we see that f double prime of pi by 6 is equal to minus sine pi by 6 plus root 3 cos pi by 6, right? Now here we are not going to solve this expression because we are interested only in the sign of the second derivative, and the sign of second derivative, it comes out to be negative, right? So here we have the negative sign, and this shows that the double derivative or the second derivative is less than 0, and by second derivative test we conclude that x is equal to pi by 6 is a point of maxima, right? It is a point of maxima because the second derivative is less than 0. So in this way we have shown that this function has the maximum value at x equal to pi by 6, and the maximum value of this function can be obtained by substituting x is equal to pi by 6 in this function. So it can be written as f of pi by 6 is equal to sine pi by 6 plus square root of 3 times cos pi by 6, and sine pi by 6 is half, and cos pi by 6, that is cos 30 degrees, this is root 3 by 2. So we have half plus root 3 times root 3 is 3 over 2, and this is 4 by 2, that is equal to 2. So therefore f pi by 6 is equal to 2. So this is the maximum value of the function, right? Now let us take this problem. Here we have to find the absolute maximum and minimum values of the function f of x is equal to cos square x plus sin x, where x belongs to the interval 0 to pi. Now here we have this function, and let us first find out the derivative of this function, right? So let us call this function as y equal to f of x. So dy over dx is given by 2 cos x, and then we have here minus sin x plus the derivative of cos x is sin x is cos x, right? So this is taking cos of x common. So here we have cos x times minus 2 sin x plus 1, right? So the derivative is given by cos of x times minus 2 sin x plus 1. Now for the critical points, the derivative should be equal to 0. So dy over dx should be equal to 0. So let us solve this equation, that is cos x times minus 2 sin x plus 1 is equal to 0, right? Now here we have either cos x is equal to 0 or minus 2 sin x plus 1 is equal to 0. Now this equation can be written as sin x is equal to half, right? And this is cos x is equal to 0. Now we have to find the values of x. Now from here, from this equation, we have x is equal to pi by 2, because cos 90 is equal to 0, and from this equation we have x equal to pi by 6, because sin 30 is half, and we have one more value of x, that is 5 pi by 6, right? 5 pi by 6, and these three values, that is pi by 6, pi by 2 and 5 pi by 6, all these three values belongs to this interval, right? Now we have these three critical points, and we have to see which point is the point of maxima and which is the point of minima. Now here let us apply the second derivative test, and to apply this test we have to differentiate this function, that is f prime of x. It means we have to find out the second derivative. So the derivative dy over dx is given by this expression, and this expression can be written as cos x. This is cos x, and this is minus 2 sin x cos x, and we can write it as cos x minus 2 sin x cos x is sin 2x, right? Now let us find the second derivative. So the second derivative is the derivative of cos x is minus sin x, and here we have minus 2 cos 2x, right? Okay, now this is the second derivative, and let us substitute these values in this expression. So now at the first point, that is pi by 6, we have the value of the second derivative as minus sin pi by 6 minus 2 cos. Here we have pi by 6, which is equal to pi by 3, right? And while we calculate the values of the second derivative, we usually we do not have any interest in the numerical value, but we are interested only in the sign, right? So here we see that sin pi by 6 and cos pi by 3 are positive quantities, so this whole expression is negative, right? Okay, now for x equal to pi by 2, the value of this expression is minus sine pi by 2 minus 2 cos, here we have pi by 2, so 2 and 2 get cancelled, so we are left with only pi. Now sine pi by 2 is 1, so here we have minus 1, and cos pi is minus 1, so this becomes plus 2, so here we have 1, so the sign is positive, right? Okay, now at x equal to 5 pi by 6, the value of this expression is minus sine 5 pi by 6 minus 2 cos, here we have x is equal to 5 pi by 6, so cancelling out this 6 by 2, we have 5 pi by 3, right? So now, as we have said earlier, that while we calculate the values of the second derivative, we are not interested in the numerical value, but we are interested only in the sign of the second derivative at that particular point, right? So here the value of sine pi by 6, because 5 pi by 6, it lies in the second quadrant, and sine is positive in second quadrant, so here we have this negative sign, and sine pi by 6 is positive, so the overall sign is negative, and cos 5 pi by 3, and here 5 pi by 3, it lies in the fourth quadrant, right? It lies in the fourth quadrant, because 5 pi by 3 is 360, and here we have 300. So 5 pi by 3 is 300 degrees, and it falls in the fourth quadrant, and in the fourth quadrant the cos function is positive, so here we have negative and here we have positive, so the overall sign is negative, right? So here this quantity has negative sign, this quantity has negative sign, so the overall sign is negative, right? So we conclude that at x equal to pi by 6, right, at x equal to pi by 6, the function has a local maximum, this is local maximum, and at 5 pi by 6 also this is negative, so this has local maximum, and at x equal to pi by 2, the value of or the sign of the second derivative is positive, so at x equal to pi by 2 we have local minima, right? Now let us find out the values of the function at these points, right? So here we are given the interval 0 to pi, so we'll also calculate the value of the function at these two endpoints, right? So these are the points which are obtained by equating the derivative equal to 0. So these are the critical points, and these two are given as the endpoints of the interval. So now we have to evaluate the value of the function at these 5 points, right? So these 3 points are the critical points, and these 2 points are the endpoints of the interval from 0 to pi, right? So the value of f of pi by 2 is given by this expression by substituting x equal to pi by 2 here. So cos pi by 2 is 0, so this is 0 square plus 1, that is 1, and f of pi by 6 is cos square pi by 6, which is root 3 by 2 whole square, plus sine pi by 6 is half, so this is 3 by 4 plus half, that is 5 by 4, right? Okay, now f of 5 pi by 6, that is equal to cos square 5 pi by 6 plus sin 5 pi by 6. So the value of cos 5 pi by 6 is minus root 3 over 2, and here we have the square plus here we have sin 5 pi by 6, which is equal to sin pi by 6, that is half. So this is 3 by 4 plus half, that is 5 by 4, right? So 5 over 4. Now here f of 0 is cos square 0 plus sin 0, and this is cos 0 is equal to 1. So here we have 1 square, sin 0 is 0, so here we have 1, and here cos pi is minus 1, and here we have square, sin pi is 0, so this is 1, right? So viewers, here we have obtained these 5 values, right? So we have 1, we have 5 by 4, again 5 by 4, then we have 1 and 1, right? So we see that the absolute maximum is 5 by 4, and this occurs at x equal to pi by 6 and 5 pi by 6, right? And the absolute minimum is 1, and it occurs at x equal to pi by 2, then x equal to 0, and then x equal to pi, right? So the absolute maximum value of this function is 5 over 4, and it occurs at x equal to pi by 6 and 5 pi by 6, and the absolute minimum value of this function is 1, which occurs at pi by 2, 0 and pi.